class. In today's class, we are going to be discussing about Hello, welcome to class. In today's class, we will be discussing about projectiles. In the diagram I drew above is that of an object thrown with an horizontal velocity of u equal to 10 meters per second. The height of the cliff from which the object was thrown is h and is given to be 50 meters. We are to find the time taken to reach the ground. B. The vertical component of the velocity when the ball hits the ground. C. The distance from the foot of the cliff where the ball hits the ground. We should note that in solving this type of question, the ball falls vertically under the influence of gravity. Okay, its vertical motion is independent of the horizontal motion. So please note, this object, a ball thrown in this way, is performing two types of motion. One, it is falling under gravity, and that is why the ball is dropping from where it is thrown to the ground. Two, the ball is also moving forward away from the cliff. So simultaneously and independently, the ball is performing two types of motion. The ball is performing vertical motion and the ball is also performing horizontal motion. Therefore, the equations of motion that we already know, we can write it in form of the vertical component of the motion, the vertical motion of the ball, and we can also write it in terms of the horizontal motion of the ball. Now, since we are asked to find the time taken to reach the ground, we will use the formula that we already know as one of the equations of motion, which is S is equals to ut plus half at squared. But recollect that we have said that if the ball is moving in air, we should use h instead of s. Okay, so h just stands for the height instead of the s, which is ordinarily known to be the horizontal distance. We will use h, which is the vertical distance. So h, therefore we can write that h is equals to ut plus half at squared. H is equals to ut plus half at squared. In terms of the vertical motion now, we can write h subscript v is equals to u subscript v t plus half a subscript v t square. Don't forget that we are writing it in terms of the vertical motion, and so all of the vectors in the equations we are to use the vertical component. For example, hv is the vertical height, okay, which is also the vertical displacement, and you know that displacement is a vector quantity. uv is the initial vertical velocity. Of course, velocity is a vector, and so can be we can show the direction. T is a scalar quantity, and it does not take any form of maybe of either horizontal or vertical, so we leave it just as it is. Then we have A, which is the vertical motion of A, there's vertical acceleration, which is also equal to our g that we already know, g that is approximately equal to 10 meters per second square. Then the t also is a scalar quantity. Okay, we can go ahead to substitute now. The initial vertical velocity is 0. Why? Since the object is thrown horizontally, the object, if you look at the diagram here, look at the direction with which the object is thrown. The object is thrown horizontally, so the vertical component of the initial velocity with which the object is thrown is 0, which is represented with u subscript v. The acceleration, a subscript v, which is the vertical acceleration, is equals to g, and g is equals to 10 meters per second square. Then we have the vertical height, which is the vertical displacement, that is the displacement, the height that the object, that the ball covers downwards, okay, is 50 meters. Now, going substituting, we have our h v subscript v to be 50. We have our u subscript v to be 0, that is the initial vertical velocity is 0, okay, times t plus half times 10 times t squared. Okay, so anything times 0 is 0, and then 2 here, 1, 2 in 10, that gives us 5, and that gives us 5t squared. Okay, so divide both sides by 5. We have t squared is equals to 10. When square goes to the other side, it becomes square root of 10, and that gives us our answer, gives our t to be equal to 3.16 seconds. For the b part, let v subscript v be the final vertical component of the velocity. Okay, don't forget we are to calculate the vertical component of the velocity when the ball hits the ground. The vertical component of the velocity when the ball hits the ground. Okay, to do that, we will take our initial vertical velocity to be u subscript v, and it is equals to 0, just as I have explained before. Using v square is equals to u subscript v square plus 2a subscript v h subscript v. Okay, so that gives us our u subscript v, which is the initial vertical velocity, is to be 0, then 2 times our a subscript v, which is the vertical acceleration, which is our g, is 10, then the vertical height covered by the ball is 50. If we multiply this will give us 1000. Okay, so if square goes to the other side, it becomes square root of 1000. Okay, and that gives us our v to be 31.6 meters per second. 31.6 meters per second. Okay, let's go to the c part. Let s subscript h be the distance from the foot of the cliff where the ball hits the ground, using s is equals to ut plus half a t squared. Okay, so I will just, in this case, for the c part, we are looking for the distance from the foot of the cliff where the ball hits the ground. Automatically, we are looking for this distance, the distance from the foot of the cliff, which is this place, to where the ball landed. Okay, so this is the distance that we are looking for when we are calculating the c part. So we are looking for this distance, which is what, s, okay, and h, that's the sh that we are looking for. Okay, so to do that, we will use the formula s is equals to ut plus half at squared. Then we'll write that equation in terms of the horizontal motion, which is what, s subscript h is equals to u subscript h times t plus half a subscript h t square. Okay, then our s subscript h is equals to our u horizontal, initial horizontal velocity is 10. Okay, which is the 10 given here, the 10 that we were given here. Then our t, which we have calculated before now, is 3.16 seconds. Okay, then plus half times our horizontal acceleration. Horizontal acceleration is 0. Our horizontal acceleration is 0. Why? That is our h is equals to 0. Why? Because the object is coming to the ground. Okay, the force of gravity is pulling the object to the ground, and that is why our horizontal acceleration is 0. Don't forget, that shows the technicality behind this type of problem. Then times our t square, which is 3.16 square. Okay, so if we do this, all of this becomes 0. 0 times anything gives 0. Okay, then we have 10 times 3.16, and that will give us 31.6 meters. That tells us that our sh, which is the distance the object, where the object lands from the foot of the cliff, is 31.6 meters. I hope you enjoyed this class. We'll meet again in the next class. Take good care of yourself. Bye.